Hello everyone, and welcome back. This is our fourth lecture for Chapter 1. In this lecture, we will continue our focus on defining basic terminology and explaining some of the foundational concepts. Specifically, we are going to cover research design and types of studies. So let's begin with design of statistical studies. In order to have valid and reliable data to analyze, researchers must begin with good study design. The design of the study is the most important part of research, more important than data analysis, for one very simple reason. No amount of analysis can fix a badly designed study. The saying, garbage in, garbage out, is appropriate here. This is exactly what a researcher gets if they don't design a good study. Good research design is also very important for consumers of information. When we read about research findings or results, we must pay attention to how studies were set up and conducted to determine the accuracy of the results or findings. Researchers follow steps to design and conduct research studies. Most of you will be familiar with these steps. So step 1 is to identify the population and variables of interest. A researcher will state a hypothesis or tentative prediction for an observation, phenomenon, or problem that can be tested. In order to be testable, the variables that we're studying must be clearly defined. These clear definitions are achieved through what we call operational definitions. Operational definitions specify exactly how the variables in question are to be observed and measured. For example, if I want to study memory, I can operationally define memory as the number of words recalled from a list. Another example, if I want to study aggression in children, I can operationally define aggression as the number of times one child hits or pushes another child. In both of these examples, I can tangibly measure my variables. In step 1, researchers must also clearly identify who their population of interest will be. So in my second example, I would have to identify what the age are of the children I am interested in studying. Step 2, develop a detailed plan for collecting data. In this step, a researcher needs to decide how to put the hypothesis to a scientific test. They can choose to test their hypothesis through different methods, descriptive or experimental. Once the method is chosen, then the researcher must make a detailed plan for carrying out their study. The researcher will also have to get approval through their institution's review board to conduct their study. Step 3, collect the data. Once approval is given, a researcher will collect their data through observations, interviews, questionnaires, psychological tests, biological recordings, and so on. Step 4, describe data using descriptive statistics. Once the data are gathered, a researcher uses descriptive statistics to provide graphical and numerical summaries of the data. If the researcher is working with population data, then there's no need for step 5. Population data do not require inferential statistics. Remember that inferential statistical procedures are used when we do not have population information and we are using sample data to make predictions about a population. So if the researcher is working with sample data, they will go on to step 5. interpret data, and make decisions about the population. In this step, a researcher uses statistical procedures to determine whether the sample data support the hypothesis, then draws conclusions about the population based on analysis of or evidence from the sample data. Step 6, identify possible errors and make recommendations. The final step is for the researcher to identify any possible errors and make recommendations. In all studies, there will be room for improvement. Researchers can't think of all the possible things that can happen in a research study. So things happen and errors are made, and that's okay, because the research process is a learning experience. There are two main types of studies, experiments and descriptive studies. It is important to know what each of these are and how they work. Your research questions and hypotheses will determine which study is most appropriate to use. As consumers of information, it is also important to determine whether the appropriate study was conducted and whether the claims being made or the findings being reported are appropriate for the type of study that was conducted. We will start with experiments. In an experimental study, a treatment, procedure, or program is intentionally introduced and a result or outcome is observed. Researchers compare results between those who received the treatment and those who did not. Any study that demonstrates cause is called an experiment. To demonstrate cause, though, an experiment must follow strict procedures to make sure that all other possible causes are eliminated or highly unlikely. So researchers must control the conditions under which observations are made in order to isolate cause and effect relationships. Let's look at an example of an experiment designed to determine the effect of room temperature on student test scores. A sample of students was selected from a population of all undergraduates. In one group, the room temperature was 70 degrees while students took the test. Normal temperature, or what we call a control condition or control group. In the other group, the room temperature was 90 degrees during the test. Increased temperature in this case, or what we call experimental condition or experimental group. The test scores in both groups were then measured and compared. For this study to be called an experiment, researchers must satisfy 3 requirements. These requirements are the necessary steps needed that allow researchers to draw cause and effect conclusions. Here are the requirements: manipulation of variables, random assignment of participants to conditions or groups, and comparison of control condition or group. Researchers use random assignment to place participants into groups. In order to do so, researchers manipulate or vary or change the levels of an independent variable to create the groups. Going back to our experiment example, the independent variable was room temperature. Room temperature is what changes from group to group. The researcher manipulated or changed the levels of this variable. One group worked in a 70 degrees condition, and the other group worked in a 90 degrees condition. The researcher created those conditions. They then assigned each student at random to experience one of those conditions, one of the levels of room temperature. Random assignment and manipulation ensures that characteristics of participants in each group, like their age or study habits, are about the same in each group. This makes it more likely that any differences between the groups will be caused by the manipulation of room temperature and not the participant characteristics like their age or study habits. So in our experiment example, researchers used random assignment, so requirement number 2 is met. Researchers manipulated room temperature, requirement number 1 was met. And researchers compared test scores between the experimental 90 degrees condition and the control 70 degrees condition. So requirement number 3 was met. So our example is an experiment. Now we've introduced some basic terminology in our scenario that some of you may be familiar with, but in case you are not, let's quickly refresh everyone's memory. Room temperature is our independent variable with 2 levels or conditions, 70 degrees as control or normal temperature and 90 degrees as experimental or increased temperature. An independent variable is the variable that a researcher manipulates or varies to see what changes occur or how it impacts another variable. It is the presumed cause. Test scores is our dependent variable. A dependent variable is the variable that's measured or counted in each group and is believed to change in the presence of the independent variable. It is the presumed effect. The logic of experimental studies is that if everything is held constant, then a change in the dependent variable, test scores in this case, was caused by the manipulation of the independent variable, the increase in room temperature. Or, the independent variable manipulation causes changes in the dependent variable is another way of looking at it. Now, independent and dependent variables are not the only variables that are in experiments. We also have what are called confounding variables. Confounding variables are those variables that researchers did not account for and might be the reason for the changes in the dependent variable. In our experiment scenario, a confounding variable might be the time both groups took the test if they took it at different times of the day. Controlled variables, however, cannot be confounding variables. So, for our scenario, if both groups took the test at the same time, so they're controlled, time is controlled here, then time cannot explain the changes in the dependent variable, and therefore time cannot be a confounding variable. So here's another great example of confounding variable. If you want to show that smoking causes heart issues, what are some confounding variables? And here is our experiment scenario. You can take a minute to review what we just covered. Now, there are times when an experiment is what we call a quasi-experiment. It is almost an experiment because one of the requirements is not met. Here are 2 types of quasi-experiments. Non-equivalent groups, where the researcher compares groups, but they cannot control who goes into which group. So, for example, researchers who measure differences in multitasking behavior by sex, here the independent variable sex is pre-existing. Participants are already male or female prior to the study. Researchers cannot manipulate the variable or randomly assign participants to each level of sex. So this study is quasi-experimental. The other type of quasi-experiment is the pre- and post-test, where researchers measure participants at 2 points in time and they cannot control what happens between the two time periods. So, for example, participants may have matured or been affected in some way during that time period that might affect their test scores. In certain situations, descriptive studies are the optimal way to go. The most common descriptive studies are polls and surveys. When the goal is simply to find out what people think and to collect some demographic information, for example, gender, age, income, and so on, surveys and polls are the best, as long as they're designed and conducted correctly. Descriptive studies are used when researchers are not able to manipulate or control the variables they want to study. This lack of control means that descriptive studies can never be used to show cause and effect relationships between variables. So let's start with observational studies, or as they're also called, naturalistic observations. These are the careful and systematic observation of behavior without direct intervention or interference. For example, children's spontaneous acts of aggression on a playground during recess are observed. Or Jane Goodall's research with chimpanzees was naturalistic. She observed chimpanzees in their natural environment. Or Dian Fossey's research with mountain gorillas was also naturalistic observation. A simulation study is a virtual study. Participants are put in virtual environments to see how they respond. Researchers also use simulation studies to test phenomenon that might be difficult to test in real-world settings using physical or mathematical models. Examples of simulation studies include flight simulators used to train pilots, driving simulators used to test how sleep deprivation affect reaction times, or military war games are used to train soldiers, and so on. Surveys include the use of questionnaires, personal or telephone interviews to gather information about specific aspects of participants' behaviors. For example, children are given a questionnaire that describes hypothetical scenarios and are then asked about the likelihood they would commit the aggressive behavior. Market research are other examples. Public opinion polls are survey-driven.